audio. I've got recording. We are good to go. All right, let me just put this all here. All right, so what I'm going to try and show you how to do today is get my mouse. Is to get this Arduino to actually take an input from the outside world and to do something with it. So we might call this reading an input. When we were turning the LED on, we were, writing to an output. We were, doing something. We were sending data out. Today, we want to get some data in. Now, to do that, we have this circuit over here. And let me take you through this circuit, right? So the part that we already have, right, that is the LED that is connected to pin D2. So when we tell D2 to turn on, D2 becomes positive, becomes plus 5 volts. And so current can travel through the LED, through our 220 ohm resistor, through to ground. And if we've got current flowing through our LED and it's going the right direction, then our LED is going to turn on, right? That bit we know. The bit that we're going to do today, or we're going to introduce today, is we've got a switch in here. And that's this guy here. Right, now these switches cause my brain to hurt because this is a what we call a single pole, single throw switch. And the simplest way to draw that is like this. So you've got one sort of pole. That means you've got, essentially one sort of connection. And you've got one throw, which means that it only connects to one other thing. But these switches, they've got 4 legs, right? 1, 2, 3, and 4. But they're still considered single pole, single throw switches because these legs are connected to one another, right? So you could treat this switch as if it were just this. Right, it's a single pole, single throw switch. Now, what's connected to that single pole, single throw switch? Well, we've got one side of that switch connected through this resistor to ground. So this side of the switch is connected to ground through this, and that's supposed to be a 10k ohm, so 10 kilo ohm resistor, and that goes to ground, right? So this point of the switch is at 0 volts. And D5, that's connected to, again, it's connected to this leg of the switch, so that's also connected to ground, so it is also by default at 0 volts. And so pin D5, that is seeing, if you like, 0 volts. What happens when you push that button? So when you push that button, you close that switch. So like that, and that becomes a pathway. So that's connected to 5 volts. And so now all of a sudden, you've got 5 volts, and that is connected to pin D5. So pin D5 is now seeing 5 volts. So when you close the switch, pin D5 is seeing 5 volts. And we've also got that 5 volts connected to ground through that 10k resistor. So there's a little bit of current going through this pathway, through our resistor and to ground. But because the resistor's down here, we measure, at this point above the resistor, we would measure 5 volts. And at this point below the resistor, we would measure 0 volts because all of the voltage will be dropped across that resistor. So basically, we got a switch, right? And when we close the switch, pin D5 sees 5 volts. When we open the switch, pin D5 sees 0 volts. And this is what we use to be on and off, right? So, 5 volts would be on and 0 volts would be off. And that's a digital sort of logic because something can be either on or off. So that's digital. So we'll just have a quick look at what this looks like on our actual circuit. So we've got, pin D2 going to our LED, going through this resistor to ground. That bit we had from last time. This time, we've got pin D5 over here, right? And that wire goes all the way to our switch. So that's this here, pin D5 going all the way to our switch. And then this leg of the switch and this leg of the switch, they are always connected to one another, Right? That's just how it works. And so pin D5 is also connected through this resistor through to ground. And then when we push the button here, what we do is we essentially close the little switch that exists here, and now that 5 volts is connected to ground, and it's connected to pin D5 through this blue wire. So when we push the button, that's what's happening, right? When we push the button, pin D5 is seeing 5 volts, and when we let go of the button, pin D5 is not seeing 5 volts. So we've got a few little new commands that we need to get comfortable with. And the first of those is setting up our pins as an input. So pin mode is the command that we use. That we know from last time because we used pin mode to set up outputs, but now we just change it to input. We also need to use a command digital read. So previously we used digital write, and that was how we turned something on or off. So digital read is how we tell if something is on or off. Instead of writing, we're reading. And the other thing that we're going to do is we're going to use this switch to make a decision. And for that, we are going to use what's called an if else loop, if you like. So if a thing is, a thing happens, do something else. Else, so that's if it doesn't happen, do something else. All right, I'm going to show you how to put all that together. All right. So, first things first, we've got an LED plugged in. So let's create that LED on pin 2. So we're going to call that let's just stick with int. So we're going to go to int, and we're going to give it a name, LED, and we're going to say that it is plugged into 2. And now we need some more variables because we've got a button now. So we can say int button, and that one is plugged into 5. And lastly, we are going to create a variable that isn't actually a pin. So this variable is not connected to a pin. So it stores the info from the button. So we're going to call this one int button state. And I'll do that in camel case because that's a good habit to get into. Camel case is this stuff where you use a capital letter between two things. And we are going to set this to 0 to start off with. So we are just going to say that this sort of button, this variable that we call button state rather, it is just set as being 0 to start with. All right, so we're going to come down to our void setup, and that's the place where we set up inputs and outputs. So we're going to type in pin mode, and our LED is an output, and our button is an input. And it's important to get, it's not so important to get your outputs right, but it's really important to get your inputs right. If you set a pin up as a button, it basically connects it to a little resistor inside the microprocessor on the Arduino, and it makes it much less likely that you're ever going to blow it up. So if it's an input, set it as an input, kind of important. All right, and sometimes I just like to put some spaces in my loops just so I can read that a little bit more easily. Now, I need to, I'm just going to put a couple of spaces in here so that sort of opens up and we can see. All right, so the first thing I need to do is I need to tell the Arduino to actually, read the button or to pay attention to what's happening on the button. So read the state of the button. And to do that, I tell it that this thing that we've created, so this thing called button state, is going to be equal to a digital read of this thing called button. And all that's saying is that, okay, so this variable we created called button state, I want that to be equal to whatever you're seeing on the thing we call button, which is the button plugged into pin D2. Right, and then we need to give it some commands. So we're going to say it to tell the LED if the button is pushed. And to do that, we use an if-else loop. And the way that you work that is you write in if, and then you open some brackets, and you put your statement in there. So like, if this thing is true, so what thing are we looking to be true? We are looking for button state to be equal to high. And important to notice that in C, which is this language, double equals is actually the sign for is it equal to. A single equals is the symbol for make this thing equal to. A double equals is test if this thing is equal to. So if the button state is equal to high, then we open a curly brace, and now we put in our command. So digital write LED high, and that's going to tell our LED to turn on if our button is pushed and it's high. And then we come down here, so that all lives, this command lives inside these curly braces here. And then we're going to put in our else, and we're going to open another curly brace. So else is a way of saying, you know, if that isn't true. So if it's not true, what do you want it to do? Well, I want it to digital write LED low. And you can see that this command lives inside these curly braces, and the Arduino IDE has nicely, you know, put in a couple of curly braces there to keep things right. Now, do I expect you to remember, you know, like digital write and digital write low and where all the curly braces go and all of that sort of stuff? No, that would be ridiculous. That's not how people, it's not how most people learn things anyway. You learn things by doing it, experiencing setbacks and having to go back and relearn things. And so if you know, needed an example of how this works and the code, you could come over here to digital, and there's an example for button, right, which shows you how to set up a button. It also gives you a website that gives you an example. If you want to, you know, control, here's if statements, here's a bunch of different stuff. You know, there's heaps of examples built into this IDE that will be really useful to you when you're learning to write code. Now, what this should do when you upload it is when you push the button, right, the button state is high, the LED should turn on. And when you let go of the button state is not high anymore. It goes back down to 0 volts. So it turns the LED off. So upload that and see how you go.